Hi, this is Miss Fizone, and this is Graphing Hyperbolas. So this is graphing hyperbolas when there's an x in the numerator. So far we've only done ones where there's a number in the numerator. So let's see what happens. Okay. The only thing that doesn't really change for a hyperbola where there's an x in the numerator is the vertical asymptote. Because remember, the vertical asymptote is where the is the domain, basically. What can you not have when you have a fraction? You can never have 0 in the denominator. So x minus 1 equals 0. So x equals 1. Okay. Now your horizontal asymptote is a little bit different. Okay. Before, the horizontal asymptote was the whole fraction could never equal 0. This whole fraction can equal 0 now because of that x. If you plug in 0, you can actually get that as your horizontal asymptote. What this will never equal is you have to look at the relationship between the x's. So what we're going to do is take those two x's, take your x in the numerator and your x in your denominator, and divide them. What's x divided by x? That's 1. Y equals 1 is your horizontal asymptote. If you try to set this fraction equal to 1, it's never going to solve. You're not going to be able to solve it. It's impossible. Right? It's never going to happen. You're going to get something like 2 equals 3. Right? So we're going to take the highest x on the top, highest x on the bottom, and divide them. Okay? So I'm going to draw those. So we have x equals 1 and y equals 1. Here's my y equals 1 horizontal asymptote, and x equals 1. All right. So now the method for finding a point on the graph that I gave you was I said to set the numerator equal to the denominator. Look what happens when we try that, though. If you try to solve this equation, what do? We got to get all the x's together, so we minus x on both sides, and we get 0 equals negative 1. Is that true? No. Cannot do that. All right? So here's what we're going to do. We're going to just set, because there's an x in the numerator, we're going to set the numerator equal to 0. Okay? We're going to set the numerator equal to 0. So point number 1, what's the numerator is just x equals 0. Plug 0 into the function. What do you get? 0 over 0 minus 1. 0 over negative 1 is just 0. So 0, 0. So my first point is 0. 0, 0. So I'm going to plot that to start. Now, there's not a really good way to find the second point. So here's what you can do. Notice that hyperbolas are symmetric. So what we're going to do is we're going to do a reflection. I don't know if you remember reflections from geometry. We're going to reflect this point over both of our asymptotes. So if I count, how far is this point from my vertical line? 1. So I go 1 more. So I'm at 2. So my second point is going to be 2 something. 2 something. All right, point number 2. Okay, my point number 2, it's going to be 2 something. Because I'm at 0, 0. I count 1, count 1 more. Now I'm going to go reflect up. Count 1, count 1 more. So 2, 2. And then also, if you're not comfortable with the reflection, just do the x value, and then when you get 2, plug 2 into the equation. What do you get? 2 over 2 minus 1. 2 over 1 is 2. All right? So those are your points. Now that reflection actually works on the other one also. So in the other problems we were doing, if you do a reflection, you can find the second point that way also. All right? So this process is a little different. All right, so here are your steps for finding your asymptotes. All right. So vertical asymptote is the same. You set the denominator equal to 0 and solve. For your horizontal asymptote, divide the highest term in the numerator by the highest term in the denominator. And that's going to be, remember, that's a y equals. Okay, that's a y equals. All right. For the points, point number 1, we set the numerator equal to 0, and we plug in to get the y coordinate.